So what if you wanted to weigh something? But something that's not exactly the size of an elephant, but more like the size of a tiny little ion. Well, it's not exactly possible with a scale. I mean, you can't even see where it is. Fortunately, a big brain by the name of Francis W. Aston came up with the idea of mass spectrometry. This provides a way for us to measure the mass of super tiny charged particles using cool stuff like electric and magnetic fields. There's a bit more behind how actual samples' masses are measured, but here's how you can measure the mass of charged particles. So the first step of the process is an accelerator, and as you can probably guess, this accelerates the charged particles. In this step, a voltage is used to create an electric field. It's usually created by a set of charged parallel plates. And the stronger the electric field is, the faster the particle will go at the end. In terms of conservation of energy, this works because the particle moves from an area of high potential to low potential, and that leftover energy is converted to kinetic energy. Next up, we have a velocity separator, which is a really cool thing that lets particles with only a certain velocity through. This thing uses uniform electric and magnetic fields to deflect particles based on their velocity. So here you can see the magnetic field deflecting a particle downwards that has a velocity of 12 meters per second. And if we crank it up to 40, it's deflected upwards. But if you find that nice sweet spot right there around 20, it goes straight forward. That's when the magnetic field and electric field both exert the same force upwards and downwards. Let's take a look at how this actually works. Okay, so for the mass selector, we know that it consists of an electric and a magnetic field. Let's take a look at how the magnetic field acts on, for example, a positive particle coming through the mass selector. Okay, so we're going to move it in here, and we see here with the X's that the magnetic field is pointing downwards into the page. So which way is the force acting on it? Well, if you guys have done your homework, you should know that we're going to use the right-hand rule. So we're going to point our fingers in the direction of the velocity, which is right over here, and then make it so our fingers are deflected by the magnetic field. And as you can see, the magnetic force is pointing upwards. So there's going to be an upward force acting on this positively charged particle. If the particle is moving here with an initial velocity, we're going to see that it's going to be deflected upwards. And it's not going to make it through to the next stage. So let's have a look at the electric field. So say we have an electric field pointing downwards, and this is going to act on our positive charge by deflecting it, or putting a force on it that is directed downwards. And over here we see that magnetic force is QVB. So say we have just the same amount of charge, but our velocity has to be just right so that the magnetic force equals the electric force. And it doesn't matter for this, since there's no velocity in here. But if we have exactly this right velocity, it's going to head through straight because the two forces equal each other. And in this case, if the velocity is too small, then the electric force is going to be greater and it's going to drag it downwards, so it won't make it through. And if the velocity is too great, here the magnetic force will be stronger, and then they'll be uneven again, and this charge will be deflected upwards. So it has to be just right to make it straight through to the next stage. So the final part in a mass spectrometer is the mass separator. This part simply consists of a magnetic field that ends up exerting a centripetal force on the particles. This works because the magnetic field always exerts a force perpendicular to the velocity of your particle. Let's take a look at why this really works and how we can figure out the mass from that radius. From our velocity selector, this particle comes in with our specific velocity, and now again with the right-hand rule, we can find out. Put our fingers in the direction of the velocity, make them so the field that's going into the page deflects them, and our magnetic force is directed upwards. This is going to make our particle move upwards. There we go. So now, again, if we do this, point our fingers in this direction, the magnetic force is still going to be pointing upwards, but it's always perpendicular to the velocity. So in the end, what this is going to do is it's going to make our particle kind of form a circular arc that curves around and back towards a fluorescent screen here on the side. And then what this will do is let us see visually where these particles have landed. And using a radius, like from here to here, we'll be able to find out, using this equation right over here, the charge to mass ratio, which takes in the initial velocity and a radius that we formed here and the magnetic field strength. So there you go. That is a mass spectrometer. Anyway guys, hope you had fun watching this video, and see you later. Cheers!